In this video, we're going to talk about strength of redox agents. So we've seen this chart, and let's first of all read the rules. Oxidizing agents is the reactant from the half reaction with a more positive E half cell. And the more positive the E value, the more readily the reactant, the side here, will act as an oxidizing agent. In other words, these things prefer to be reduced. The more negative the E values, the more readily the product will act as a reducing agent. In other words, these products really prefers to be oxidized. Okay, with that being said, let's talk about a specific case. In other words, I want to reiterate this one more time. Fe2 gas and Cl2 gas really prefers to go from 0 to -1, the oxidation numbers, and gain that electron and to be reduced. NaLi, these are first element metals, right? First group element metals. These really prefers to be in the ion state, oxidation number going from 0 to +1, and B, we're losing an electron, so that's oxidation. So this really prefers to be oxidized. F2, Cl2 gas really wants to be reduced. NaLi really wants to be oxidized. Okay. What that means is, for example, let's do Na plus and Cl minus ions. Let's say we dissolve some salt in water, and this can potentially form, right? Cl2 gas and Na solid. This would have to be balanced by, so we need 2 Na plus, and then we form 2 Na, and then we need 2 Cl2 at 2 Cl minus to get Cl2 gas. So now our reaction is balanced. But the thing about this is that we already know that it is very unlikely that Na plus ions and Cl minus ions will react to form Na solid and Cl2 gas. It is very possible, but they don't want to do that, right? Na really wants to go the other way, and Cl2 gas really wants to go the other way. But let's still calculate the reaction potential for this reaction. We have Na plus going to Na. Okay, that is, and remember that the moles do not matter. Na plus going to Na, signs are consistent. We have negative 2.71. Cl minus gas, Cl minus ions going to Cl2 gas, moles do not matter. In this case, our arrows are flip-flopped. We want it to go this way, right? So we're going to put a negative 1.36. Adding those two gives you 704 minus. That's a very negative reaction potential. So this is a very non-spontaneous reaction. It will not spontaneously occur. However, on the other hand, if the arrows were going this way, right? Let's say for somehow we try to put Na solid gas and Cl2 gas, Na solid and Cl2 gas in water and try to form Na plus and Cl minus. I'm just putting twos to make sure that our reaction is balanced. And this would be actually just the opposite, 4.07 reaction potential, right? And these are all voltage. This is a very spontaneous reaction and is very likely to occur. Okay, with that being said, let's look at this problem. The more blank the value of E half cell, the greater the driving force for reduction. The answer is positive because the more positive the E cell value is, the stronger of an oxidizing agent it is. If it's a strong oxidizing agent like F2 and Cl2, they really want to be reduced by gaining that one electron, right? So they have a greater the driving force of reduction. Okay. What we were talking about in SI was that we were talking the more the negative the EHAV cell value is, Na and Li are very strong reducing agents. They would much rather be oxidized. Therefore, in these cases, like we saw in Na and Cl2 gas, making Na plus and Cl minus ions, these really want to be oxidized. So they're very strong reducing agents. Therefore, we'll have a driving force to make Cl2 be reduced. That's the reason why I thought that the answer would be B, but this question is simply asking whether the reactant itself would be readily be reduced. That's the reason why the answer is A. To summarize really quick, higher the oxidation number, not the oxidation number, higher the reaction potential of voltage gets higher and more positive, the stronger of an oxidizing agent the reactants are, therefore will be really want to be reduced and will have a greater driving force to be reduced. Strong oxidizing agent really wants to be reduced.